During my session, I hope to show you how easy it is to create your first machine vision application with our software. By this, I mean both the vision algorithm and also the HMI panel, which can be used to display the results of our inspection and to adjust some parameter of the application. Okay, so now I'll start by sharing a screen. Okay. In my presentation, I will only focus on the demonstration by using our software. Yeah, so I really hope you will find it very interesting. And I will basically create a very easy application from the start to the end, completely in our software. Okay, so the first thing that you can see by opening our application, so Adaptive Vision Studio, is that it mainly consists of three different parts. On the left side of the screen, you have the catalog of the filters available in our software. It is grouped by different type of categories of filters, and it consists of the most commonly used filters in our software. For the first application, it definitely should be enough to simply use the filters that are visible here in this toolbox category. But it is good to know that if by some chance this is not enough for your needs, then we have the even bigger set of filters. I think at the moment above 3,000 present in the filter catalog. Here. Okay, so here we have the option to choose our filter, which can be used to perform many various types of operation. It can be used to inspect the image, to pre-process it, to perform some kind of operation, to send the data to some external device. All kinds of operations can be done using those filters. After you select your filter, you have an option below to set the properties of this filter. How exactly does this work? I will show you later. But basically, first, while creating your application, first thing you need to make sure to select and set proper properties of your filter on the left side of the screen. Then you move your filters to the middle section of the screen, to the program editor. Here, you connect the filters with each other so that they exchange the data with themselves. As a result, you are creating your application here. Okay, so after you've done this and after you run your application, you have the option to preview the results. And for this purpose, you use the right part of the screen. And here we have the preview window. In it, you can display the results of various inspection. You can check the outputs of every single filter that you have in your application. And then by taking a look at those values, you can actually modify your application. Okay, so that would be, I would say, all for theory. Now let's start working on the application. Well, to create our application, the first thing that we need to do is to have some image on which we'll be working. For this purpose, we have the option to use the filters from the image acquisition category and also image acquisition third-party category. Very commonly in our application, we are using images acquired either from the file or from directory. For this purpose, we can use the filter from files. And here we have enumerate images, which loads images from the directory, or load images, which load a single image. There's an even easier way to add this filter. We simply drag folder or file directly from the Windows Explorer to our program editor, and that way we have a new filter in our application. However, in this application, I will rather use image acquired from the camera. There are many different ways in which we can acquire those images. In in vast majority of the program, we are using either GigaVision compatible GigaVision filters or GeniCam filters. Those filters, or rather those category of filters, can be used to either acquire or to basically to work with the devices compatible with those standards. If you take a look at our website, you will see there are list of the supported hardware, and the first sections of the hardware that is supported there include either GeniCam or GenTL compatible devices. So if your camera is compatible with it, you can use it in your application. So here I'm clicking on GigaVision tool in my image acquisition category, and here you have the option to choose the filter that will be used in your application. So in this case, I will use the most common one, GigaVision Grab Image filter, synchronous variant. In the majority of the applications, you don't really have to worry about choosing this correct filter for this purpose. The default one will be sufficient. Okay, so in my application, I will use this particular filter. We have also used an option to use GeniCam filter for the purpose of acquiring images. Actually, if I recall correctly, by using this filter, we are personally able to work to acquire images from the Basler Blaze camera, and I personally have used this device in one of my projects, and it worked really great there. If your device is not compatible with those standards, so GigaVision or GeniCam, then for some of the manufacturers, we have also added direct support filters that can that use their SDK, and you can work with them in this way. And as you can see, we have quite a few manufacturers here. So even if they are not compatible with the standards, in the most popular cases, you should still be able to work with those devices. For the full list of the available filters, please take a look at the hardware support list at our website. Okay, so now that I have added my filter to the program editor, I need to make sure that it's correctly that its properties are correctly set. If you take a look, after selecting the filters, in this case, I have only one filter, you will see in the left bottom of the screen its properties. In this case, one of the properties that is available for this filter is marked with the stripes here. That means it is mandatory input, and we need to set this value before we run our application. In this case, this is input called in address. So to acquire image from our camera, we need to make sure to specify which camera we want to use. So I'm clicking on this icon here, and then I am able to select the camera I want to use by using the advanced editor, GigaVision Device Manager. Currently in my network, I have two cameras. I'm going to use the point gray camera, which I have next to me on my setup here. So I'm using it here and clicking select. As you can see, it was quite easy. There was no need to check the IP address to check what kind of name this camera has. All that we needed to do is to select it from the list of available devices. Okay, so now that I have specified this, I can also modify the other properties, or rather inputs of this filter. But in this case, it's not really necessary. I should be able to acquire a great result with the default values. So now I'm going to run application. To run your application, you can use those icons with the arrow here. And in the majority of the cases, you use either this icon to run your application continuously, or this one to iterate it and to simply acquire only a single image. In this case, I'm going to run it continuously. Those additional icons here are also used to execute your application, but they are more commonly used while debugging your application and when you are want to execute only some small part of your application. In this case, I'm going to use the most common option here, so I'm going to run my program continuously. Okay, so I can see that the progress bar is moving here, so I assume it is running. It is indeed running in this case, as you can see by checking also the status in the top left, bottom left corner, but it's not really interesting at all right now for us, because I cannot really see anything here. To see the result of our filter, all that you need to do is to grab the output of the filter, or input if you wish, and to drag it to the right section of the screen, to the preview window. Okay, and now you can see the image acquired from my camera. And I'm going to use this particular object, some kind of methodical object, to perform some kind of inspection on it. I'm going to use also the backlight, so the shape of the object is very distinct, and it is easy to detect its edges, which will be extremely helpful at the later point. Okay. Yeah, so we have our images, and now we need to perform some kind of inspection. Before I go to the part with the inspection, I need to first make sure that I will be able to perform those inspections in the precise location where I need to perform them. In this case, I assume that it is possible for my object to slightly move its location. So before I perform any kind of operation on it, I will need to make sure to locate this object, and then I will be able to by using the coordinate system acquired that way, I will be able to perform my inspection in this particular place on the image. So for the purpose of locating my object, I'm going to use filter, which is aptly named locate object. It is located in the computer vision 2D category, and here you have locate object. So once again, I'm dragging it to my program editor. As you can see, there are several options to choose here, but as I'm going to use for only single object, and I'm going to look for the edges, because they are quite strong, quite distinct in this particular image, I'm going to use the single variant of the locate object edges filter. Of course, other variants are also helpful, but rather in different types of application. In this case, I should be able to achieve a correct result with this one particular filter. Okay, I'm adding it to my program. And first thing, as before, I need to make sure to set the mandatory inputs. Here I can see that I have two such inputs in image. So I'm going to use to connect to it image acquired from my grab image filter. How to know to which exact output I need to connect this input? It's quite simple. If you click on the input or output or any port of the filter and move it to the side, you will see the output of the same type will be highlighted. So right now you can see that out frame is of the same type, and I can easily connect them with each other. As a result, the image acquired from the camera will be then passed to my locate object edges filter. Okay, so I have taken care of one parameter. Now I need to take care of the another one. And this parameter is called edge model. So once again, as in previous case, I'm using the advanced editor, graphical editor to define, to create this model. In this case, for this particular type of data, I need to specify to mark a characteristic part of the object that will allow us to precisely locate it in our images. In this case, I think some part of this corner here should be sufficient in this case. So I'm going to mark it. Let's say like this. I assume that I can slightly decrease the rotation because I know, for example, that in this particular case, the user will not move the object too much. So it should be fine to restrict it slightly. So I'm going to click OK, and I'm going to generate the model. Okay. Of course, there are other properties here, but for such a simple case, it should be definitely enough for the application to work with the default values of those parameters. So I'm going to run the program, and to see the results, I'm going to display out object match on the preview. As you can see, the box which represents the position of my object is moving together with my object. So this is exactly what I wanted. So now that we have it, we can perform some kind of inspection on this object. What I'm going to do? Well, I'm going to perform various things. First thing that I'm going to do is to measure the distance between two of those circles here. For this purpose, I need to first make sure to fit geometrical shape, in this case circle, to this image, to this part of the image, and then to measure the distance between them. So I'm going to do this just now. For this purpose, I'm using the filter once again from the computer vision 2D category. Here we have fit shape, and I'm going to use fit circle because I want to fit circle to this image. And as I'm working basically on the edges, which are the location in the image with the high contrast, where there's a transition from the very bright pixel to very dark pixels. So I'm going to use, in this case, fit circle to edges filter. I can stop. And as I'm going to fit two circles to this image, then I'm simply copying and pasting this image, this filter here. So now I need to connect image. As you can see, once again, in image is highlighted here. So those are the ports of the exactly the same type of data. And now I also need to make sure to connect out object alignment, which basically describes the position of my object in the position of my object in the image. So I'm connecting out object alignment, and I'm passing it the in fitting field alignment. As you can see, once again, it is highlighted. So you don't really have to think to which of the inputs of this filter you need to connect it. It is quite easy to select the proper one in this case. And now I need to also make sure that I specify in which exact part of the image I'm going to perform my inspection. Okay, let's run the program to this point. Here I have my out object alignment, which moves together with the image. And now I need to specify in fitting field. So I'm going to use once again advanced editor. So it should be advanced graphical editor. So it should be quite easy for you to create, to set proper values for this filter. And in it, I simply mark in which location of the image I expect the hole to be. Okay, I have done this for the one object, and I'm doing this for the another one. Okay, should be enough. Let's run the program. And let's display circle and second circle. As you can see, I am able to locate both of those circles in the images, even if the position of the object changes. So it is exactly as I wanted. Now I'm going to measure the distance between those two circles. For this purpose, I need to find a filter which will perform this operation. But what should I do if I'm not exactly sure what type of filter I need to use? Well, if at least you know what type of data you're going to pass to this filter and what kind of output you want to receive, then it's quite simple to find such filter. All that you need to do is to write simply in the search engine of the toolbox, is to write in and then colon, and then you specify the type of the data. So I'm looking for the filter which takes point to the input, and it returns output. So I'm writing out colon, and this output will be of the type segment. Yeah, that's right. And now I have the smaller list of the filters which fits those requirements. So it's quite easy to find right now that the filter that I want to use here is called point-to-point distance. So I'm going to add it to my program, and to use it, I need to connect both points to it. So the problem with it right now is that that I need to make sure to somehow acquire the center of my circles, and to do this, of course, there are several ways of doing this. I can either use some specific filter for this purpose, but in this case, it's even simpler way is by using the property output. If you have advanced type of data, so in this case, for example, circle, then by right-clicking on it, you have the option to select the property output. So basically, it consists of the simpler type of data, which are the part of this more complex one. In this case, in the case of the circle, it have inside of it the center point, and I'm going to use it in my operation. So I'm doing similar thing for the another circle. So out circle, and click on the center, and I'm connecting it to the point 1, and here to point 2. Now I'm running my application, and as you can see, I have the segment between those two circles. So the first inspection was performed correctly. Now I'm going to perform another one, and basically here I'm going to detect and count the amount of circles present in the image. For this purpose, I'm going to use the filters from the segment image category, and this filter will be extract blobs intensity. And how exactly does the filter work? Well, it's extract the parts of the image that fits the specified requirements. So we can look for the pixels that are bright enough, and then split it into separate objects. So I'm going to run my application. I haven't yet specified anything in this filter, but I'm displaying out blobs. Maybe I need to make sure. First, I need to make sure to slightly specify minimum area for my blobs, and now I'm going to display it. Yeah. So as a result, it show me the location of the circles. But in this place comes another great part of our software. Even if you don't really know how exactly every single filter works, by using our software, you can easily easily simply run your application and then modify its parameters of the properties of your filters while your application is running. As a result, you will be easily able to see the results of each inspection in the real time, and as a result, you will be able to correctly set the parameters so that you will achieve what you want. Okay, so yeah, I think I also want to set some maximum area here, so only those objects are found, and maybe higher minimum area. Yeah, okay, it looks like you work correctly. Yeah, so right now I'm only locating those circles, and I'm locating them because I have specified the proper values of their area, and as a result, I can later, at a later point, count how many of those circles I have found in my inspection. Okay, so I think the last type of inspection that I'm going to show you right now is that I'm going to, well, let's run the application, is that I'm going to detect the situation in which this circle, this rectangular part in the middle is not fully visible. So for this purpose, I'm going to use another type of filter, another commonly used filter, which is called check presence. Once again, it's located in the computer vision 2D category. And I'm going to use the most basic filter version of this filter, so check present intensity. I'm connecting image, and I'm also connecting this out object alignment so that I will always perform this inspection relative to the position of my object. And I'm specifying region of interest. Let's run the application once to this point. Okay. So now I have the option to define in which particular location I will be perform my inspection. So I'm going to check the presence of the object here. Let's run the application. Let's also modify the way my preview window works, because it is quite, in our software, you have very many options to modify the way it looks. You have option to split it into different windows. You can option to undock some kind of windows and move it to the other monitor, and it makes working with more complex application or any application at all much easier. So I have my my new window, and I'm going to display here out intensity. And what this tells me is the intensity value in this particular location of the image. As you can see, it is quite small right now. So by setting the proper values of the min intensity, max intensity, I should be able to detect situation in which this is the case. So right now it's around 27, but if the whole part is visible, it's around 94. So let's set minimum intensity to around 50. And as a result, you can see now out is present value. It tells me that this out is present value is false. So in this case, I can assume that this is some kind of defect. But if the whole place is visible, then it is true. If it's partially visible, in this case, we classify this as false. So another inspection have been correctly performed. So now that I have my application, and and I can create my HMI panel. In this case of this another filter that I have shown you, check present intensity. Hopefully, I have shown you that that with our software, it is very easy to debug your application. Even if with the default value, something is not working correctly, you can simply run your application either with using this continuous run or by using iterate option. You can run your application that way, and then you can modify the parameters of your filters, and then you will be easily able to see how it affects the results of your inspection. So I'm moving the mean intensity, and it affects the result of this last inspection. Okay, so now that we have our inspection done, we need to somehow convert those type of results to results of the type of Boolean type. So it will simply tell us whether this object is correct or whether this is not the case. Once again, we have the filters that can be used for this particular purpose, but it's much easier to simply use the formula for this purpose. What exactly is formula? Formula allows you to write a simplified code that can be used to combine the result of your inspection. This type of code is similar in its complexity to the Excel language, so it shouldn't be really too difficult to create your application. So I'm going to create this type of inspection here. So I'm adding results, inspection results. Okay, I have specified it, but now I need to also have an access to some kind of input while computing this value. So I can either connect it directly outputs to this formula block, or I can label those outputs so that I will be able to use it in this formula without the need to create any additional connection. So I'm going to do this right now. So I'm clicking here, right click on the check presence output, and I'm going to call it all is present. Okay, so I have one input. Now I'm going to do the same for the out distance, which simply tells me the numerical value for the distance between those two circles. I'm going to call it distance, and I'm going to use it on the output from this filter. I don't actually need the regions which are corresponding to those opening, but rather I need simply to have the access to the number of them. So I'm right-clicking on the output out blocks. I'm selecting property output, and here I have the count property output. Now I have my new output. I'm right-clicking on it again and selecting option to label it. So I'm going to call it circle count. Okay, and I'm simply writing the code. So in call it distance, it automatically suggests me the name of this value. If distance is bigger than, let's say, 200, then this have the value of true. But I'm also going at this point combine it with additional inputs. So I'm going to pass it. I'm going to check here circle count. Circle count in this case equal to 8, and I'm going to check once another thing if hole is present. So it will basically check all those expression, and if all of them are true, then the whole inspection result of this inspection will be also true. As you have seen here, there was no need for me to specify the type of the data that will be on output of this formula. It was automatically selected. Okay, now it looks that the algorithm part of my application is correct. So I'm going to create HMI panel. The preview windows are only visible for the developers, which are working on the application with in the Adaptive Vision Studio. But if your end user would like to be able to take a look at your application and to see the result and modify it, then you need to make sure to create the HMI panel for them. With our software, there is really no need to install any additional software. Everything is included in the studio. So I'm clicking on the HMI design here, and you have now on the left side of the screen new tab visible, HMI controls, and I can use it to add many different types of control to my HMI panel. I'm not going to describe all kinds of controls here because, of course, there are many of them. But in this case, I'm going to describe the most commonly used ones. In this case, I definitely think that we need something to display our image in. So for this purpose, I'm going to use indicators category, and here we have view to the box pass fail. So I'm dragging to the HMI panel. I'm increasing its size, and as you can see, here we have some inputs which you can connect it by dragging output of the filters directly to those inputs. So first input is an image. So I'm basically going to connect image from my camera. Next, we have data. Here we need to connect any type of geometrical data that we want to display on our image. In this case, let's start with connecting the segment between those two circles there. So I'm going to connect out connecting segment. Okay. And in status, I can connect the Boolean value which describe whether this particular inspection or data that I have connected previously was computed correctly or not. So in this case, I'm going to connect it value of this expression, distance bigger than some kind of value. And for this purpose, I will simply create some additional output for this filter. So I call it distance OK. It will be of the Boolean type. And not like this, but there are here on the output, distance OK. And I simply connect it like this. Okay, I can also move it to this side, and that way I will reuse this particular value here, out distance, okay? And now I have the option to use out distance, okay, here. And let's see the result. Of course, I can modify the way in which this particular control is displayed. In this case, as there is really no, in this particular case, the distance between those two circles is the same for all our images, then this distance, this inspection is correct. But I can also add this. I can also add additional data to this control to display those additional data there. So I'm adding additional output here. I'm going to call it circle count. Okay, and I'm going to simply copy this part of code here. Okay, and I'm moving it to the top of our formula, and I'm exchanging this with the out circle count. Okay, and now I can connect here out blobs to the in data, and I can connect out circle. Okay, And in the end, I have the option to do the same for the check present filter. In this case, I have the option to use it directly from this filter. So I'm connecting whole is present to the data status and out align region of interest to this. And now I'm running my application. And okay. So yeah, so as I am locating all 8 of those circles, then I am drawing them green. If I were, if by some chance one of them would not be present, then I would mark them red. If, on the other hand, this particular part would not be fully visible, like let's say here, then I would mark it in red. So it would tell me that the inspection, this particular inspection was not correct. Okay, yeah. So as you can see, by using our software, you can also easily show the result of inspection. The last thing, because I think I have taken quite a long time to show it in my presentation. The last thing that I'm going to mention is that if you want to add your end user to ability to change the settings of your program, then it's easily possible to do so. It's just, for example, adding control from the controls category. Here you have, for example, knob, and you can connect it to any of the, for example, to this formula, and then this value, which is set by the end user on this control, will be then used to set those threshold values, for example, for this distance. In this way, the end user will be easily able to affect your algorithm, and in that way, it will be easily able to work with it. Okay, now that you have created your application, yeah, you have the option to export it to the either AVX file, which can be used by running our software, or you can have the option to also export it to C++ or .NET code, and as a result, you can easily combine your machine vision application, which, as I hope you have seen, you can create very easily with our software, with more advanced application, more complex application that you are creating with some kind of different application, different type of software. Okay, thank you for your attention. And now, if you have any questions, then please let me know.
Hi, Mark. Thank you for that. That was brilliant as usual. And it does just show how powerful and yet easy to use your software is. We have got one question. Is it possible to define variables in a formula node that will not be used as an output of the formula block itself?
Yeah, so I assume it is something like this. It is not possible to add it as some kind of temporary variable, but if it is really problematic for you to see those values and you are not really using it in any particular place in your application, then you have the option to let's remove the connection. Then you have the option to hide this output. Okay, and I think, yeah, I think that should be possible to use it, but I'm not exactly sure what
node. And like you say, you've hidden it away. I hope that answers the question. If the gentleman who posted it, or lady, I should say, who posted it, wants any further information, please just put your hand up and we can unmute you so you can join in the conversation. I think that must have answered the question. If anyone does have any questions afterwards, though, please feel free to contact me, and we can pass those questions on to Adaptive Vision, and they're very quick in answering normally. One other thing I should mention is that demonstration version of Adaptive Vision Studio is available to download. Now, if you want to contact myself, I can forward you a link to it, or if you visit the Adaptive Vision website, it can be downloaded from there. So unless anyone has any more questions, thank you very much, Mark. That was brilliant. And we shall restart with our next presentation at 11 o'clock. So, thank you, guys.
Thank you. Bye.